Okay, this video is all about triangles and inequalities in triangles. And what the main idea is that angles and sides in a triangle have relationships. And they have special relationships that involve inequalities. And I've actually already gone over this once this year, so if you've been with me all year, you have learned this. If you haven't, then this will be the first time you've heard this. One of the things that I think the first thing that we have to go over, I think, is redundant, but it still needs to be said. These two are called remote interior angles, and they add up to this exterior angle. So whatever 2 plus 3 is, that's the measure of angle 1. So let's say that the measure of angle 2 was 50, and the measure of angle 3 was 40. Well, that wouldn't be it, but let's make it something different. Let's say it was 30, then the measure of angle 1 would be 80, okay? Because they have to add up to be the measure of angle 1. That's a rule, okay? That's not stated here, but it's something that we've already learned. So I don't know why this has to be stated. This corollary says that the measure of angle 1 is bigger than the measure of angle 3. Well, obviously, obviously it's bigger than angle 3. And it also says that the measure of angle 1 is bigger than angle 2. Well, obviously it's bigger than angle 2. I don't know why they have to say this, because we already know this. That's like saying, let's actually put numbers in again. Let's just say it again, 50, and let's say 40, oh, no, what was it before? Let's make it 60, okay? So let's make this 110, because it looks bigger than 100. Let's say 110. You know, obviously, this is bigger than 60. And obviously, it's bigger than 50. Of course it has to be, because together they add up to be the measure of angle 1. I don't know why they need to tell us that, but that's the first thing that we have to go over, is that the measure of the exterior angle is more than each of the remote interior angles. But we already know that, because we already know that they add up to be the exterior angle. So one of those things, I don't know why they have to tell us that, but whatever. It's really simple. We'll take it. It's an easy grade. So we'll read it. It says the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. Of course it is. You know, that's like saying 4 plus 6 is 10. Therefore, 6 is less than 10, and 4 is less than 10. Well, obviously, that's true. You know, it can't be any other way. But whatever. Okay, so let's move on. That's pretty obvious. Okay, something that, again, if you haven't been with me all year, this will be something new. This is the relationship that triangles and angles have. I call it like a marriage, okay? The larger angle, if y is the largest angle, then it'll be across from the largest side. So the largest angle is right across, right opposite from the largest side. Like they have a relationship, okay? And the smallest angle is directly across from the smallest side, and the medium angle is directly across from the medium side. They all have that same relationship. They usually focus on the small angle and the large angle, but it doesn't matter. They all have the same relationship. And then down here it says the exact opposite, that the longer side lays opposite the larger angle. So if this is the longest side, then you know that this is the largest angle. And again, makes sense. Like they actually have a relationship. And we'll practice this and it'll make more sense. So right now you just need to kind of absorb this as much as you can. Angles and sides have a relationship in a triangle. Whoever is right across from you, like when you're looking directly across the table or across the triangle, they have a relationship with each other. The triangle inequality theorem, when you read it like this, it looks super confusing, but it is not confusing. I'm going to make it super easy. In fact, I'm not even going to read this because I'm going to make it much easier than this. So we're just going to go straight into some examples, because if I read this to you, you're going to feel like you're overwhelmed, but it's not hard at all. So let's go into the first example. Okay, so the very first thing that I want us to do is I want us to draw this same diagram over here as best we can. And I'm sure mine's not going to be great, but just do your best. But don't write the numbers in. We're going to make up our own numbers. So let's make this outside number, what does that look like, 120? So let's make this 120 degrees. And I'm going to make mine a different color. You don't have to, but let's make this 120 degrees. So angle 1's 120 degrees. It looks like it probably is. So if it's 120 degrees, and we know that these two have to add up to be that 120 degrees, so two numbers that add up to 120, let's make them, what do you want to make them? Maybe 80 and 40, what is it, 90 and 30? Nah, let's not do 90 and 30. Let's just do 50 and 70. Okay, let's make angle 4 50. And let's make angle 3 70. Okay? And I'll try to put my degrees up there. Alright, so based on what we already know, we know that these two have to add up to be this one. Okay, we already learned that. So we're just making up numbers here, but this is what we know. And we're just filling in. And what we also know is that these two are vertical angles. So whatever 3 is, 2 is the same thing. So if 3 is 70, so is 2 70. Okay? So now we kind of have everything written in. So we've made up our own numbers, but they could be real. You know, they look like they could be legit. So let's read. It says, explain why the measure of angle 1 is greater than the measure of angle 2. Well, for one thing, it's pretty obvious. I mean, angle 1 is definitely obtuse, and angle 2 is definitely acute. But we can't take the diagram for the way it looks, because a lot of times they won't draw the diagram to scale. They'll do that on purpose to throw you off. So you have to use your geometry, and you can't go off the diagram. So we do have to use geometry to prove it. So here's what we do. We've actually already used geometry to prove it. What we know is that these two have to add up to the remote out here, which they do. And we also know that these two are vertical, so they have to be the same. So it has to be that this is more than this. There is no other way. So if we were verbally saying a proof, then we've already done it. Like, we're done. If you were saying it out loud, you would say, well, 3 and 4 add up to be the measure of angle 1. And 2 and 3 are equal because they're vertical. So 2 cannot be larger than 1 because 2 plus 4 equal 1. I hope that makes sense. Again, I don't know why they're making us do that. It seems so obvious, but maybe it's one of those things that are going to come in handy later when we're proving something. But nevertheless, it's pretty simple, and I don't think they make it very hard on us. So, okay, so they want us to list the angles of each triangle in order from smallest to largest. So here's what we know. This is the smallest side. So therefore, the angle directly across from it would be the smallest angle. So the first angle is M. Then we look for the next smallest, which would be 4.3. And directly across from it is angle L, So angle L is next. Then 5.8 is the longest. So angle K would be it. And that is Martin Luther King, actually. It's kind of funny. So angle M, angle L, angle K, in that order. That is the list of angles from smallest to largest of that triangle. The next one's a little bit trickier. So let's look at it. Notice that they don't give us all three sides, but they give us two sides and an angle. What we know about triangles is that this is an obtuse triangle. Obtuse triangles have one obtuse triangle and two acute angles. I'm sorry, one obtuse angle and two acute angles. So we know that this is the largest angle, therefore this is the largest side. So if we're looking at these sides, I mean it could be 5x, let's just say. We don't know what it is, but let's just pretend that it's 5x. As long as it's bigger than 3x, we're fine. Now that we have the sides, we can do our job, okay? We know that 5x is the largest side, so therefore E would be the largest angle. But we're going for smallest, so let's start with the smallest first. So D would be the smallest because it's across from the X. D would go first, and then 3x would be across from the C, so C would go next. And then 5x would be across from the E, so E would go last. Make sure that you're understanding, and if you're not, raise your hand, okay? Because this is actually not hard, but it can get confusing. The best way to think about it is when you're on the side, it's the angle that you're not touching. Notice that I'm touching the K and I'm touching the M. It's the other one, okay? If that helps. Kind of like a barbell. You know, I'm touching the K, I'm touching the M, so it has to be the L. Okay, the next thing we're supposed to do is list the sides of each triangle in order from shortest to longest. They give us two of the angle measures, but they don't give us a third. But again, we're supposed to know how to do that because we already know that all triangles are add up to 180. So the first thing that we're going to do is take 180 minus 45 minus 75 to get the missing angle, which is 60. Okay, so this one is 60 degrees, if you can read that. Now that we have the angle measures, now we can think about the sides. And this is not hard, but it can get confusing for students, especially when they're so small like this. So I'm going to rewrite it and make it bigger so that it's easier for us to see. So I got 60 here, 45 here, and 75 here. Okay, and I have O, M, and N. And I'm only doing this because it's so tight that it's hard to really see. So let's see. Okay, we're going from shortest to longest. So we're going to start with the 45. So 45 degrees, I'm going straight across. That would be MN. So the first side is MN. Make sure we put our bar over it, make sure it's a line segment. So the shortest side is line segment MN. I put my comma, and I go to the next one. The next side is 60. That would be the next shortest side. And I circle it, and I go straight across, and that would be ON or NO. It doesn't matter which one you choose. I'm going to go with NO. Put my bar over it. And then the last one, of course, would be MO or ON. It doesn't matter. I'm going to go with MO. And then I'm done. I have now listed the sides from shortest to longest. And we're going to do the next one. So go ahead and try the next one by yourself. See if you can get it. Pause the video and then watch the video and see if you got it right. Okay, so this one you should have had 42 here. And then you could have drawn it again. and I am going to. And it doesn't matter if you don't draw it exactly the same, as long as you get your letters right. And I got 28, 42, and 110. So I should have got FH, and then I would have had FG, and then I would have had GH. So hopefully you got that. If you did not, you need to raise your hand and ask me questions, and make sure you understand everything. Okay, I know we're going over a lot in this video, but you can always pause the video and watch parts of it. But this stuff isn't not that hard, it just takes a lot of notes. So the next part is they give you 3 sides of a triangle and they ask you whether that triangle is even possible at all. Sometimes the answer will be no, that triangle would never even exist because one of the legs isn't long enough to create that third leg. Like if you draw the triangle, it might look like this, you know, and that would never exist. So the easiest way to figure it out is to just pick 2 of the sides. It does not matter which 2 sides you pick. Let's just pick 2 and 3. Okay, they give us 2, 3, and 6. We could have picked any 2 of the sides. I just picked the 2 easiest ones. And I do 2 plus 3, and I get 5. Okay, then I do 3 minus 2, I subtract them, and I get 1. And I always add them and subtract them. Same thing every time. So the third leg would have to fall in between 1 and 5. It could not be 1. It actually can't be 1, and it can't be 5. It can't be exactly 1, and it can't be exactly 5. It could be 2, it could be 3, it could be 4. It could be 2.1, it could be 2.2, so forth. You know, it could be 4.1, 4.9, that kind of stuff. But it cannot be 5, exactly, 5.0. Like, it can't be 6. Like, 6 is too big. So this would be a no. It could only be 2, 3, or 4, or anywhere in between that. Think about a number line. It could be 1.1, you know, anywhere like that. Hopefully this is making sense. I might draw a number line. So for example, I have, here's 1, and here's 5. On a number line, open circles mean that they cannot include that number, but anywhere in between that. So think about this. I have 1.1, and I have 4.9. Anything in between there would work. So I got 1.2, 1.3, 1.4, and so forth. I also have 1.02, 1.03, and I have an infinite amount of numbers in between those two. But it cannot be 1, and it cannot be 5, and it can't be bigger than 5, and it can't be less than 1. So just make sure that that is clear. So this one actually would not work because 6 is too big. It had to be in between 1 and 5, and it was not. So let's try the next one. So the first one was a no. That triangle could not exist. So let's pick this one. Let's do 11 and 12. So we're going to add 11 plus 12, and we're going to subtract 11 and 12. So 1 again, and then we have 23. So anywhere in between, oops, I think I wrote it wrong last time. Yeah, I did. I'm sorry. I should backfix that. Make sure that you have your inequality symbols facing this way. I messed that up. So fix that in your notes. But as long as it's in between 1 and 23, then you're good. Obviously 15 is fine. 15 falls well in between 1 and 23, so this is a definite yes. This triangle could exist. It cannot be 1, and it cannot be exactly 23, but it can be in between, and that's fine. Okay, so when they give you two sides of a triangle and they ask you what is possible for the third side, we do the exact same work that we just did. You know, we subtract them and we add them. So we do 12 minus 8, and we do 12 plus 8. So we get 4 and we get 20. So your answer is, as long as it falls in between 4 and 20, and it can't be 4 and it can't be 20, then you're fine. And that's our answer. Like, literally, you write it exactly like that. Don't put, don't do this. That's wrong, okay? Make sure you have just no equals, okay? So try the next one and see what you get, and then play the video. Make sure you get it right. Okay, so for 28, you should have got in between 11 and 21. And then for this one, you should have got in between 0 and 12. So hopefully you got those, and if you did not, make sure you ask questions because I am definitely here to help.